All right, find the requested value, number 50. So we've been asked to find f of 2 for the function f of x equals, and again, we have a piecewise function. So we have f of x equals 2x plus 1 if x is less than 1, f of x equals 2 if 2 is less than or equal to x and less than or equal to 6, and lastly, f of x equals 2 minus 5x if x is greater than 6. So let's see. If they want us to find f of 2, let's see which piece of this function we're going to use based on the domain restriction. So where does 2 fall in the domain based on what we've been given? So we're going to use this first piece if x falls within the domain for this particular piece. So let's see. 2 is less than 1. Is that a true statement? No, right? That's false. That's not true. So we're not going to use this piece. How about, let's skip to the bottom here. 2 minus 5x if x is greater than 6. Well, let's see. Our x value that we're plugging in is 2. So we'll say 2 is greater than 6. Is that a true statement? Nope. Again, we get a false statement. So we're not going to be using this piece of the piecewise function. Well, that just leaves us with this last piece here, doesn't it? We're going to say f of x equals 2x if 2 is less than or equal to x, less than or equal to 6. So we have 2 less than or equal to x. Well, what's our x? 2 less than or equal to 6. Is this a true statement? Well, let's see. 2 is, yeah, definitely less than or equal to 6. So this piece, this part is true. And then we also have 2 is less than or equal to 2. Well, this less than or equal to makes this part true. So the whole inequality here is true. So we know we're going to be using this piece of our piecewise function to evaluate. So f of 2 is equal to 2x, so 2, and we know our x is 2, so we're going to plug in that value, equals, well, 2 times 2 is just 4, and so there we have it, easy peasy. F of 2 equals 4. That is the requested value for number 50.